So in this video, we're going to talk about evaluating functions. And a lot of times when you hear about evaluating functions, this function machine idea comes up. I remember learning about this back in high school and kind of being confused a little bit. So hopefully I can kind of clarify it. A lot of times you'll see this in textbooks and hear from math teachers about this function machine thing. So basically what I did is I started out with saying that f of x is 2x squared plus 4x minus 5. And what I'm asking us to do is we're going to be plugging things in for x. So wherever we see x's, we're going to be plugging in other stuff. So in the first example, I'm going to plug 4 in. In the second example, instead of f of x, it's f of negative 2, so I'm going to plug in negative 2. And in the third example, I'm going to be plugging in m instead of x. So let's start out with the f of 4. What we're going to do is everywhere we see an x in this function, we're going to put a 4. So it's going to be 2 times 4 squared plus 4 times 4 minus 5. All right, so 4 squared is 16, so it's 2 times 16 plus 4 times 4 is 16 minus 5. And then 2 times 16 is 32. 32 plus 16 minus 5. So 32 plus 16 is 48. 48 minus 5 is 43. So when teachers or textbooks talk about this whole function machine business, what they're saying is, in this example, if we take 4 and we put it into the function, and they like to use a machine because it spits stuff out, they're really saying that the function machine is doing what f of x is doing. So it's just using that function. What is spit out of the function is the output, so 43. And the whole idea is that if you put something in, you only get one thing out. It doesn't give you two possibilities out. And that's the whole idea of functions, that every input has only one unique output. You can have, let's say I plugged in another number other than 4. It's possible that you could get a 43 with a different number, but every single time you plug something in, you get only one output. That's the whole idea of this function analogy. So let's plug in negative 2. Everywhere we see an x, I'm going to put negative 2. So it's going to be 2 times negative 2 squared plus 4, the penmanship is great, times negative 2 minus 5. So negative 2 squared is 4. 2 times 4 plus 4 times negative 2 is negative 8 minus 5. 2 times 4 is 8. And then we'll just rewrite the other stuff. And we can probably evaluate this in our head. 8 plus negative 8 is 0. Minus 5 is negative 5. So in terms of our function machine, we're going to be plugging in this time, we're going to be plugging in negative 2. And what's spit out of the function is negative 5. So the input's negative 2, the output negative 5. Okay, and then the last example is f of m. So what that means is everywhere we see an x, we're just going to plug an m in. So it ends up being 2 times m squared plus 4m minus 5. And that's it. There's no like terms that we can combine. There's no way to simplify that. That's just it. When you plug m in, you get that expression. So I've got one more example we'll go over here. Let's do that. This time I've got g of x. And I just defined g of x as x minus 2 over x plus 2. And we're just going to plug some stuff in. So let's plug in 1. So for g of 1, it's going to be 1 minus 2 on top and 1 plus 2 on bottom. And so 1 minus 2 on top is negative 1. 1 plus 2 on bottom is 3. So our final answer is negative 1/3. So by putting 1 into the function, we get out negative 1/3. Let's try negative 2. So we put negative 2 in. We get negative 2 minus 2 on top. And then we get negative 2 plus 2 on bottom, which gives us negative 4 on top and 0 on bottom. And that's a mathematical no-no. We can't divide by 0, so this is called undefined. undefined. So anytime you end up with 0 on the bottom, that's considered undefined. And so a little bit of foreshadowing for the next example. If we plug in m plus 1 in for x in the top and bottom, we're going to get m plus 1 minus 2 on top and m plus 1 plus 2 on bottom. And so when we simplify this and combine like terms, we get m minus 1 on top and m plus 3 on bottom. So this expression, the output is m minus 1 over m plus 3. But when I talked about in the second example, we can't divide by 0. We have to qualify this with m cannot equal something that makes the bottom 0. So m can't be negative 3, because if you plug negative 3 into the bottom, you end up dividing by 0. So anytime you end up with a fraction where there's an expression on the bottom, you have to think, when is that going to be dividing by 0? And that is it's called a domain restriction. M cannot be negative 3 because you'd end up with an undefined situation. All right, so that's just really the basics of evaluating functions.